into quadrilaterals and other polygons. You're going to want a calculator today. Grab one if you don't have one.
Get out. No, he's not coming. It's you. No, get away.
I'll give you $1.
Get. Like what? Is that a bad thing? Well, I'm gonna take out what you said.
Okay. So we are going to stop talking about the Cheez-Its and the cookies. If we cannot manage to stop talking about them, then they are going to be banned from my classroom.
But I'm a big bag. Stop.
Open up your notes, please. So, today we're starting to talk about polygons. Polygon is an enclosed shape that has 3 or more line segments for sides. Polygons come in 2 forms. They come in the form of convex versus concave. Concave polygons are essentially polygons that kind of have these indents in them. That and like that and like that. That's what makes these ones concave. Is it looks like part of them is almost like caved in. Convex, all of the points go outwards. Most of the time when we think about polygons, convex is what we think about. Specifically, we think about regular convex polygons, but we'll get to what it means to be regular later in the chapter. If any of its sides have curves, like this or like this, that's not a polygon. A circle is not a polygon. It's got to have straight sides. Now, when we work with polygons, one of the key things that we work with in them is known as a diagonal. A diagonal is a segment that connects one corner of a polygon to any other corner of a polygon not directly next to it. Now, these diagonals help us look at certain properties within the polygons. So that's why we're going to focus in on some of these diagonals a little bit first. But we're also going to be, as we get into this chapter, we're going to be naming polygons by how many sides they have. Some of these names you already know. For example, you know the name of a 3-sided polygon. It's a triangle. What about a 4-sided polygon?
That's a square.
Squares and rectangles are examples of them, but rhombus is also an example of one. Quadrilateral. 5-sided polygon. Yes, pentagon. 6-sided.
Like a flip?
Hmm?
It's not an octagon.
Nope, that's 8-sided.
Oh.
Hexagon.
I had a guess.
Hey, I appreciate that you're guessing. 7-sided people tend to forget.
What's the thing?
It's not a septagon. It's a heptagon. 8 was octagon. 9.
Gave up. That's what I didn't know.
Is a nonagon.
Oh, sorry.
10-sided.
Decagon.
Decagon. Charlie, we're going to get back to what you just talked about because that actually is an important thing to talk about.
I told you, Jackie.
Didn't even say anything.
11 is a hen decagon.
You say a hen
Yeah.
Deca cookies.
Oh my god.
Hen decagon.
That's how I remember those.
Why is that hen?
I have no earthly idea. where the source of hendecagon came from. I did not create. I would not have called it anything. Let's make sure the snacks are not distracting us. Okay, 12. Dodecagon.
Am I slow?
Yes.
Why is there end signs? That's a very good question, Charlie. It goes back to what you said earlier, too. When it comes to polygons, polygons are not limited on the number of sides that can go on. We often think about polygons as being smaller shapes that have only so many sides, but a polygon can have an infinite number of sides. But it doesn't have a name beyond 12 other than if it has a certain number of sides. Let's say the number of sides is n, we call it an n-gon. In other words, for example, if it had 22 sides, it would be a 22-gon.
What?
Yep. If it has more than 12 sides, it is just named by the number of sides dash gon.
That's weird.
It is weird, but it's fairly simple. It's easier. Now, these two columns should have also been blacked out. So my bad on that. Now, as I mentioned earlier,
Why do we not draw pictures
you can, if you want to. There's nothing wrong with it. I just don't need you to draw a hexagon and a heptagon and an octagon and a nonagon because you know how to draw it. You just give it however many sides it's supposed to have and then you close it.
Okay.
So that's I just wanted to kind of start you off with, hey, polygon, 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 just to kind of get us thinking about polygons. That's why it's there in the first place, and it's going to help us with this. So, earlier I mentioned that focusing in on the diagonals is going to tell us something about these shapes. Now a diagonal, again, it connects one corner of the shape to another corner of the shape. It's that segment, but it can't be the segment right next to it. Or it can't be the corner right next to it. So if I look at a triangle, and I try to connect to any corner from this corner right next to it, I'm not going to get a diagonal. When I draw the diagonals off of a single corner in a triangle, I still only end up with having one triangle picture. Versus when I go to a quadrilateral, if I pick one corner and I try to draw in all the diagonals that go from that corner to all the other corners, I only get one diagonal going into the shape. Now why this matters is because these diagonals, when you come off of a single corner and you draw them across the shape, is you end up creating a bunch of triangles in the shape. And those triangles are going to help us with a property within the shape. So when I draw from this corner all diagonals that I can, which is only one, how many triangles do you see in that shape now? 2. Okay, I'm going to do the same thing here. I'm going to pick any of the corners to start with. I'm going to choose this one. And I'm going to draw on all of its diagonals. Can't draw a diagonal there because it's right next to it. I could draw one here. I can draw one here. How many triangles do you end up seeing? 3. Can you guess how many triangles are going to show up when a hexagon? 4. Can you guess how many triangles are going to show up in a heptagon? 5. Now why is this important? has to deal with the interior angle sum. What do the angles of a triangle add up to? 180 degrees. We know that from last chapter. But if you look in these bigger shapes, the angles are not going to add up to 180 for larger shapes. There's more going into those corners. There's more corners, so it's going to be bigger. But when I put the diagonals in the shape, I end up with triangles in which every corner of the triangle ends up in a corner of the larger polygon. For example, this quadrilateral, this triangle, here are its 3 corners. Do you notice that they are inside the corners of that polygon as well? They might not be the full corners, but they're part of the corner. Same thing here. Which means this triangle angle sum adds up to 180. This triangle angle sum adds up to 180. And the 2 triangles together have a triangle angle sum of, what's 180 plus 180? 360. The angles inside of a quadrilateral are going to add up to 360 because of this property, because of the fact that when I draw in a diagonal coming off of a single corner, I get 2 triangles, and 2 triangles have a sum of 360. This one here, 180, 180, 180. It's going to add up to 540.
Why is the bottom right corner white?
Because we're going to fill it in. When there's 4 triangles in the shape, I'm going to get 4 180s. Now I can add 180 plus 180 plus 180 plus 180, or what's their simpler way to do it when there's 4 180s?
Times 4.
180 times 4. 720. 5 triangles, 180 times 5, 900. Now I can keep doing this forever. But that's where that bottom one comes in. Is rather than figuring it out for every single polygon, it'd be great if there was a really easy formula to work with, so that every time we had one, we just had to plug a number in and it would tell us the answer. That's what that bottom corner is about. Have you noticed that every single time we've been multiplying 180 times a number? Specifically times the number of triangles. So, it's 180 times however many triangles there are. Now we have to figure out what is the relationship between the number of sides and the number of triangles. 3 sides, 1 triangle. 4 sides, 2 triangles. 5 sides, 3 triangles. 6 sides, 4 triangles. 7 sides, 5 triangles. What do you notice about the relationship? It's too small. It does count 1 through 5 because this counts 3 through 7. But would you agree that the number of triangles is always too smaller than the number of sides? So, if there are n sides, there are, in parentheses, n minus 2 triangles. This formula is our first theorem on the next page. So, polygon interior angle theorem. The sum of the measures of the interior angles of a convex n-gon is, in parentheses, n minus 2 times 180. Now on the front we did 180 and then parentheses n minus 2. It's the exact same thing. If you prefer it that way, go ahead and write it that way. A lot of people do prefer it that way. I prefer it that way. So how does this apply? If I want to ask you what is the interior angle sum of a polygon, You need to know one thing about that polygon. Its number of sides. I've got an example here. How many sides are pictured there? 6? 6 sides? That means n is equal to 6. N is the number of sides. So, I can do 180 times 6 minus 2. I want to simplify that down. I want to get it to a single number. What's the first thing I should do? The 6 minus 2 because it's in parentheses. 6 minus 2 is 4. And 180 times 4 is 720. Since it has 6 sides, the interior angle sum is 720 degrees. Which, by the way, matches up with what we had on the other side. So, some of the problems you're going to see today are ones like this. Let's say calculate the sum of the interior angles of the following polygons. The first one is a decagon. Again, there's one piece of information you need to know to find the interior angle sum, and that's how many sides there are. How many sides does a decagon have? 10. It's one of the ones that's on the front. It's 10-sided. Which means n is equal to 10. N is number of sides. And then we plug into that formula. 180 times 10 minus 2. Y'all got calculators. You should be typing things into your calculator unless you're doing it in your head right now. Give you another like 20 seconds to get it typed into your calculator, and then I'm calling someone. Jada, what is the interior angle sum of a decagon? You got it. Okay, problem B says an onagon. Jackson, how do I start this process?
You calculate the number of sides.
How many sides does an onagon have?
9.
What number did you say?
9.
9. I heard 90.
That's a lot of sides.
It is a lot of sides. Is there a polygon with 90 sides? Yes. Is it a nonagon? No. Diego, once I figured out that n is equal to 9 because that's the number of sides, what do I do? Okay, what's the equation going to look like? Tell me what to write. You got it. From here, we make a calculator do the work for us. You can type that entire thing in as written into your calculator. Or you could do the 9 minus 2 first and then type in 180 times 7. Zion, what do we get when we type that into a calculator? You got him. One more problem like this and we're gonna shift it up. Next one's a 23 gone. Kylie, where would you like me to start on this problem? Yes. First thing we gotta find is how many sides it has. How many sides does a 23 gun have? Don't overthink it. 23. It's specifically telling you what the number is. Charlie, what do I do with that number? We're going to end up minusing it by 2 when we put it in the formula. So yeah, you were right in both cases. What's the formula going to look like?
180 28.
You mean 23?
Yeah, same thing.
Not quite. I understand what you mean. Aaliyah, what do we get? 3,780. So, interior angle sums are going to get bigger as the polygons get bigger. So far, nothing too scary. I hope. With this, we can do the application similar to what we did with triangles, where I put angles inside the polygon and say, find x. Now in triangles, when we did this, it was slightly more straightforward because triangles' angles always added up to 180. Polygons in general don't always add up to the same number. The number they add up to is the number you get out of that formula. So when you're trying to look at these ones where there's stuff marked in the angle, you have to take a two-step approach. First, find the angle sum. Then, step 2, write your equation. So you have to do it in 2 steps. Thankfully, each step is not an overly hard step. It just is slightly more difficult than doing it with triangles. If I want to do this, I'm going to do the same thing I was just doing, just with a little bit more. Finding the angle sum. Have to figure out how many sides the shape has. How many sides does this first one have? 4. You just start counting. If it has a lot of sides, I recommend you make a dot on the first one and then you go around the shape so you know where to stop. This one's pretty easy. But as they get more and more, making a dot on where you started kind of tells you 1, 2, 3, 4. Okay, I don't go any further. Okay, 4 sides. N equals 4. Darnell, what am I going to do with that? What's that going to look like? You got it. Brody, what does that end up being? I'll give you a minute to type it into the calculator if you haven't already.
360.
You got it. So that 360 is the interior angle sum. So you add all angles equal this. That's how the equation is formed. I don't care which angle you start with, just make sure you get all of them. Again, especially as you get more angles, it's not a bad idea to put a little dot on which one you started at and then Just make sure you go around either clockwise or counterclockwise, whichever way works best for you. I'm going to start here at x. X plus, and I like to go around clockwise. 74 plus, don't forget these ones. It's one of the most common mistakes I see is people forget this one. What is that one as a number? 90 plus 141. That's my last angle, equals, what did I say they add up to? 360, the number we just calculated. Now that looks like a long equation, but does it look like a hard one? No. Mariana, if I want to solve this, what am I going to do first? I'm going to combine my like terms. I'm going to simplify it down, in other words. These are my like terms. If they're all on the same side of the equal sign, I do exactly what they say. And they say plus 74 plus 90 plus 141. 305.
Yep.
X plus 305 equals 360. Aiden, how do I solve the equation now? Yeah. $55. Did I answer the question fully? What did the instructions tell me to do? Find the value of x, then find the value of each interior angle. I got x. Each interior angle means I have to plug it back in. Am I plugging it into 74? Or 90? Or 141? Or x? Technically, yes. That interior angle is how many degrees? 55. When you are plugging it back in, try to give me some indication of which angle you're doing. If there's letters on the outside, I'll know how to do it with that. Measure angle A equals number. Measure angle B equals number. If there's no letters on the corners, then just make sure I know what's what. X is 55. This one's obvious. It's the only one. Angle. Okay. Got 2 more examples and then we're done today. Cam, how would you tell me to start this problem?
5. N equals 5.
You would start by looking at the number of sides. N equals 5. Aria, what do I do with F5?
Oh, minus it by 2 and times it by
Yep. In other words, we're plugging it into this formula. Nate, what do we end up with? Hmm?
540.
You got him. Lauren, what would you tell me to do next? They're not sides though. Right idea. Add the angles all up. Especially on ones where some of the angles repeat, I do highly recommend you do something to help you know which ones you've already added. Again, I tend to make a dot. I'm going to start on the 142. Plus 2x plus 3x plus 14 plus 3x plus 14 plus 2x. Started here and I went clockwise. Haley hurt. What is that equal to? In other words, what goes on the other side of the equation? 540. I should know by now. I stump everyone with that equation because everyone assumes that I mean simplify it down. No, write the full equation first, both sides, and then simplify. Two x, 3x simplified together. 8 x's. Oh, there's another 2x here. How many x's? 10. Good eye. 142, 14, and 14. I think that's all of them. 170 equals 540. Y'all know how to solve. 10x equals 370 divided by 10. X is 37. Sweet. Am I done? What's it tell me to do? Find each interior angle. Do you think I need to find angle J? No, I know angle J. I want to find angle K though. Measure angle K. 2x, so 2 times 37? 74. Isn't that the same as angle H? Okay, I can do that one too. Measure angle L equals 3 times 37 plus 14. 125? I'm trusting you. I haven't done the math. Isn't that the same for angle M? Okay, the last problem, we're going to start it. We're not going to go through the entire thing. Just want to make sure we're solid on the beginning steps because that's where people get messed up on this stuff. Ava, how do I start the final problem? Count up sides. Start at one of the sides, count your way around. 1, 2, 3, 4, 5, 6, 7. Now it doesn't ask this, but I'm going to ask this. Peyton, what's the name of a 7-sided polygon again? Heptagon. Piper, what am I doing with that 7?
You can plug it into the
Tell me what to write.
180 times 7 minus 2. What parentheses?
Oh, okay. Yeah, I'm gonna be baking about it. Hey, I went through all the names. New name. Going back through it. Cam, what do we end up getting?
900.
Indeed. And the last thing we're going to do is just write out the equation. Mariana, what does the equation look like? equals 900. Dot, 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 then you solve. You know to solve. For the sake of our notes, we're going to end it. Then solve. Make a pass. Okay. Hope today's stuff wasn't too scary. Section 7.1, day 1. Today's the 13th. Works due Friday. The 15th. We are in the textbook. Now, it is page 352, day 1. In other words, we're on page 352 tomorrow as well. Please do, on the top of your notebook paper, write page 352, day 1. And it's problem numbers 1 through 4, 9 through 14, 17 through 20. If you use your time wisely, I'd bet at least a chunk of you could get this done during this class. Use your time wisely.